So our next speaker is Ratnadeep Deshmane. He has recently started his own consulting company. He will tell more about it. But I want to tell about some funny thing about him. So he has been a digital nomad for a long time. I have been seeing his Instagram stories and Facebook pictures for at least 2-3 years. In 1 year, he has traveled 4 continents, 7 to 8 countries, and around 25 to 30 different cities. So that's a lot. I think he will tell something about it to us, and we can also start similar stuff, I think. Apart from that, he is also the last man standing in every conference party. So when the hotel staff asks us to close the conference, to close the gates, Ratnadeep is the last man. And I know that because I am also with him always. So without further ado, let's welcome Ratnadeep, give him a round of applause, and he will tell us something about debugging Ruby applications.
Hello everyone. So my topic is debugging Ruby memory issues, all that you need to know. I'm Ratnadeep. My Twitter handle is RTDP. You can talk to me with there. I also run a consulting company, Betacraft Technologies. Apart from that, I have been talking a lot about travel stories and stuff like that. So today I decided to talk something different, which is keyboards. So I also like keyboards, but not membrane keyboards, mechanical keyboards, if you know what that is. As you can see in the photo, in 2011, I started with TVS Gold keyboard, the kind of a keyboard you see in the banks and old government offices. It's quite low profile, but it's a sturdy and it's mechanical, and you have to use it to get the feel of that. In 2015, I upgraded to Cherry MX Blue, which is pretty loud, but very tactile, and you would love typing it, and it's also fast. These days I am also trying out Cherry MX Browns. So if you are interested in that kind of a stuff, catch me and we will have a talk about that. So apart from that, in 2012, when I was new into the Ruby, I also liked it very much. So I created a website called as My Love Ruby and collected the reasons for loving Ruby from various people. So these days I have renewed it a bit and made it whyloveruby.com. So you can go to that website and add your reasons to love the reasons you love Ruby for. So this is one of the most upvoted answer on that platform, why someone loves Ruby. And the answer is the Ruby has one of the best OSS communities ever. So applause to you. And then there are some other interesting or funny upvotes as well. Like I can be at a bar with my friends earlier while the Java guys are still typing at the office. So that's also reason to love the Ruby, right? Yeah. So the topic is debugging Ruby memory issues, all you need to know, but it's a bit of a clickbait actually. It's not all you need to know, but yeah, you need to know. Yeah, so next is story time, why I'm talking about this. So I was consulting with one of the clients so they were facing the Ruby memory issues. So the application was deployed on the Heroku. The memory used to go up and up, as you see in the graph. Sometimes it used to stay stable, and then sometimes it used to go too far ahead and then cause H14 memory vastly exceeded errors, you can see in this image. It's not that clear, but you can get the idea, right? R15 memory quota vastly exceeded. So the allowed memory is 512 MB, but application is using a lot more, up to 1 GB. So I worked with the client and then we fixed that memory issues, and then application was stable. A huge team of theirs, like a front end and a back end, couldn't do the testing, and the clients were also facing the issues because the application used to go down because of these R15 errors, and then they have to keep a watch and then keep on restarting the application, and then sometimes it used to go down again in next 5 minutes. So yeah. So when going through all those roaming memory issues and stuff, this is the guy you see quite often. So he is a tenderloin who don't know him. He is a Ruby core member as well as a Rails core member, and he is works quite heavily on the performance parts. So earlier he worked on the active record to make it faster, add some caching, and currently these days he's also working on adding the better GC algorithms to make it memory efficient as well. So I went through a lot of talks of his, and there was my colleague with me. So we looked at the talks, and we were pretty so he noticed one of the things that I also agreed with him, which is why should cats have all the fun? So if you see the Tenderlove talks, you will see that he has lots of cat pictures. The quotes are a lot informative, and those are a lot funny as well. So I thought, okay, why should cats have all the fun? So I decided to include my dog in the slides. Okay, so he is Buddy. He's on the Facebook and Insta as I Me Buddy. As you can see, he is not pretty good with the English, but he is pretty cute. So yeah, and sometimes when I debug the code and code works and I gain some wins or those nice parts that are finished, so we also celebrate. Like this is my yeah, probably video is working. So yeah, so whenever I'm working, he generally is besides me, and yeah, probably that won't work. So going to the Ruby debugging. So there are two parts that I have devised, which you should look at. First is the level 1, and second is a level 2. In the level 1 is basically it's your code or your Ruby code, and if level 1 is a your code, you can guess what the level 2 is, right? Basically not your code. Yeah. So let's start with the level 2, which is not your code, because it's easier to debug others' problem than your own problem, right? And programmers generally love that. So let's start with Ruby first. Like, what are the issues with the Ruby? Let's try to understand how Ruby memory works, and what are some of the things that create these huge memory issues, right? So first is the abstraction. When you are writing the C programs, you are yourself responsible for using that malloc function and then allocating the memory for your own use, and then you are responsible for releasing that memory back to the operating system. That's a general thing. But in the Ruby, you never have to worry about all these things. You don't have to worry about the allocation and garbage collection, right? Because there is a thing called as garbage collection, which is doing this for you. So you are basically abstracted away from that, and that basically frees you to think about the business and maybe finishing work and going to work and stuff like that, right? So the abstraction, it's a good thing, but then it also comes with its cost, and that cost is basically the memory, right? So the first part is that we will look into is the memory allocation in the Ruby, and how that works. So whenever a Ruby program is working and there are more objects allocated in the process, and whenever the Ruby knows that more RAM is required, it asks operating system to give it more RAM, right? But this operation is pretty expensive in terms of processing, right? And because of that, to optimize that, what it generally does is it doesn't ask for exactly whatever amount of memory is required. Rather, it asks for memory in chunks. Okay. To give you a simple example, if Ruby is running with the 10 MB of RAM or memory, it might ask for 10 MB more, even if 1 MB of extra RAM is required. If say 11 MB is required, it will ask for 20 MB. So it's like that. So it just tries to have a little more of a RAM available in case you need it, and to also save some processing power. So that's how typical memory usage graphs look. As you can see, like it's building up in steps, and then whenever a GC runs and it finds quite a lot of objects, it goes down, the memory usage, and then again and down and again and down, as you can see. So the important point to note here is that it's going in steps. So this is about the allocation. Next is about the garbage collection. So whenever you get the memory, now you have to give back the memory to the operating system whenever your work is done. And that is the job of the garbage collection, right? So again, just like allocating the memory, garbage collection is also the stop the world activity, meaning that what you have to do is to stop the entire processing that is happening, free up the memory or empty up the slots that we have, and then give them back to the operating system. The reason the stop the world happens is because when Ruby is, basically Ruby uses the mark and swipe algorithm for cleaning out the memory, but when that is happening, when the mark phase is happening, it doesn't want you to use the objects or basically programmed to use or allocate new objects when this process is happening, right? If that continues, then there are issues like sec faults and stuff where memory was expected to be there, but the object has been garbage collected and things like that. So that's why the stop the world is there. And so Ruby 2.1 came with the generational GC, wherein the garbage collection started to happen in 2 generations. So all the objects that are there in the Ruby heap were marked as a older generation and the newer generation. And then the idea was that the objects die young, meaning that whichever amount of objects are created, most likely they will die in 3 generations of the GC running. And having this known, Ruby decided to took the advantage of that by having a generational GC. So the objects are marked as a newer and the older. If an object stays alive even after the 3 generation of garbage cleaning, then it's marked as old and kept in a separate bucket. So because of that, what happens is the lookup is quite saved. Next is the incremental GC. So in the Ruby 2.2, the incremental GC algorithms came in. So incremental GC, what they did was earlier, say for example, if some garbage collection was taking the 10 milliseconds, instead of that, the incremental GC decided to do it 1 millisecond 10 times. So the advantage of that is the bottleneck that is there for running the garbage collector was quite low. So yeah. And next is compacting GC. So this is coming in 2.7, not yet available. But why the compacting GC is needed and what's the reason for having that there, we will discuss that in the next couple of slides. So here is how, if whatever we discussed, if we have to collect that all together and put on a graph, this is how it would look. So what I have done here is I built up Ruby application, added some users into it, and then some collections related to that, and made sure a request hits that a type of a request which will allocate large number of objects. And this is how it should. This is how it looks. So at the bottom you have this graph called as Ruby heap objects. The scale there is not linear. It starts from 0 and it ends at 10 billion. So you can see it's exponential. So whenever you see those spikes that are up there, that means there are a lot many objects, sometimes in millions. And whenever that kind of a thing happens, you can see Ruby free memory slots. So that spike goes up, and then the use of all those slots is done, and then the request has completed. But what happens is all those objects are garbage collected in one of the garbage collection process, but then that Ruby the memory that is there is not freed, and that's why you see all those spikes like the Saturday 10th, if you see that 12 AM graph, the free objects or the free memory slots was quite high, and then it's steadily declined. So as Ruby takes quite a lot, memory in the chunks from the operating system, when giving back, it also follows that principle. So it gives back in steps, in chunks. So from this we can understand that there are 3 steps that happen from taking the memory to leaving the memory. First is allocating the memory, that is in chunks. Second is garbage collection, where the memory is still with the Ruby process, but just the empty slots are there. And the third is once the slots are empty, giving that memory to the operating system. So these are the 3 steps that Ruby works in. Second problem that needs to be fixed is the fragmentation. So this is not a Ruby specific issue, but it's there with all the computer programs that run. Some of the languages these days have this fixed with the compacting GC or compacting garbage collection that is there. But what happens with the fragmentation, if you remember those Windows 98 or XP days when you have a defragmentation tools which used to open up this nice UI and then it's doing something to your hard disk, and it was quite satisfying to see that progress happening, and then so just so you know, even some people might be imagining the use of a memory in something like this, there is a memory pressure, and we see that it's half filled. There is quite much space to go above, right? So we can say 50% of my memory is in use, and remaining 50 is free. That can be used for any of the application that requires the memory, right? But in reality, that is not how the memory works. This visualization of ours isn't actually correct, And this is how it looks. So this is one of the screenshot I took from the Aaron stock, and he's currently working on compaction. So this is basic Rails application, and as you can see, even in the Rails application, there are multiple slots, and these slots are inside the pages, okay? And whenever the garbage collection happens and some of the slots are cleared, unless and until entire page is clear, you cannot give back that page to the operating system. And because of that, what happens is, you have to allocate new pages while the existing ones are half filled or pretty much inefficiently filled, you can say, right? And because of that, as you can see, it's taken up huge slot of memory, but there are a lot many white spots which are empty spaces, and that's the reason why the memory usage grows up. So in the level 1, we saw what is with the abstraction. We are sitting on the top of a GC. That's one of the reasons. And then there is a fragmentation. It's going to be fixed sooner or later, but right now it's there. And then third problem that is there in the level is the bad C extensions. So there are two types of memory issues. One is so one issue is the issue with the memory bloat, and the second type of issue is a memory leak. So the difference between these two is that in the memory leak, you have memory consistently going up and it doesn't stop at any place. And the only option that you have is to restart that Rails application, and then memory usage starts again from the low level. So you have some more time before it reaches that level where you have to restart that again, right? So that's a bad C extensions and code that is there. I remember like Ruby 2.1 had some of this issue where the memory leak was an issue from the Ruby itself, and then people were advised to upgrade as soon as possible to next versions. So yeah, so what are the solutions to this? As I was saying that Ruby 2.7 is coming with the compacting algorithms. So those are the GC optimizations that could solve. This is the level 2. And then malloc versus jmalloc. So malloc is the library that is responsible for allocating the memory in the C, right? So jmalloc is just the different implementation of that. And what people these days try to do is instead of using the malloc beneath your Ruby, you basically replace that with the jmalloc, which is more efficient in terms of these fragmentation issues and stuff. So Facebook has also contributing and using this jmalloc, so you can say it's pretty much battle tested as well. So there's a PHP stack which is also interpreted and has this GC and all these abstractions, right? And then jmalloc is helping them, so you could consider that. So all these things were in the level 2, and now we are here at the level 1, which is your Ruby code. So most likely you don't have to go and debug the issues from the level 2 that we just discussed. Most likely, or even in 90 to 95 cases, it's your code that will be the problem when these kind of issues arise. So yeah. So memory leak versus memory bloat. We just discussed some of the differences between these two, right? So how do we differentiate between these two things? And the key for that is patience. Understand, observe the memory usage. So generally it's recommended that what you should do is wait for or just let the Ruby processes run and try to understand what is the maximum level of usage it reaches. So you could keep the application running for say 18 to 24 or 30 hours, and with that finally it should settle at some point, and probably that's the maximum memory usage that your process have. So that's one way. And the second is if it doesn't stop at any of the level, then probably you have a memory leak, and then you need to if you have written any of the C extensions yourself, then you need to debug into those. Otherwise it could be a bigger issue, or it could be something from your libraries, or like level 2 side of things, right? But mostly that won't be the case. It will be the memory bloat. So yeah, this was one of the video that I had about patience. So as you can see, he was sitting in my home office, and one of his favorite person came. He expects, whenever someone comes into home, he expects everyone to greet him first before doing anything else. But now that someone is behind that door, he is waiting patiently for that. He is getting anxious as well, as you can see. Yeah, but but patience is needed. Yeah. Yeah. We can keep watching it all day. Let's go ahead. So yeah, so in one of my application, we had 512 MB of a memory. So we increased it to the 1 GB and tried to see what happens if server goes down. Yes, it was going down. Then we incremented that to the 2.5 GB, and then the application finally stabilized at around 2.2 GB of memory usage. So yeah, finally we figured out that this is a memory bloat issue and not a memory leak issue, and then we have to basically go on and optimize our code or level 1 code for the fixes. Yeah, so the first way to reduce the memory usage is to remove unused code. How genius that is, right? But let's have a look at why. So this is one of the example where you could run the derailed, which is a gem that is used for benchmarking the amount of a memory that is being used by the gems. So as you can see, there is a commands that are available at the top. So bundle mem you can use to measure the memory used by the gems, and the second is bundle objects to measure the objects created by the gems. So you can use these two commands and see amount of a memory used whenever a gem is loaded and amount of objects allocated whenever a gem is loaded. And based on that, you can decide which of the gems could be responsible for your memory issues or your memory bloat. So this is the step one. So apart from this derail, I also found a few other tools that are quite useful. One is Scout, and the second one is this Skylight. Sorry, Skylight. So the Skylight is a application performance monitoring tool. You can include that in your Rails application. It is quite light, and then what it does is it gives you time and allocation, these two options. So as you can see here, there is a time and then there is an allocation at the top. So right now I have selected allocation, and I can see all the allocations that have happened for various parts in my application. As you can see, there is a gem called as a bullet track, and it's responsible for allocating about 17,000 objects. So total of 1 lakh objects that are created there, but 17,468 are created by the bullet itself. And this was production. Can you see like what's the issue here? So basically bullet is a gem that is used for detecting the n plus 1 queries. So it was pretty good of the developers to include this bullet gem so that in the development mode, it can show you all the n plus 1 queries that are there in your application. And while developing the application itself, you can fix those n plus 1 queries, right? But then the problem was this gem was not included in just the development group of the gems. It was included in general file. And because of that, it was also running on the production. And it was doing its work of checking the n plus 1 queries, but as its default configuration is, it was not telling it to anyone, because what's the point of telling that to the users, right? So 17,000 of Ruby object allocations, which had no use at all. Pretty good fix. So we removed that bullet gem and then deployed the application, monitored it, and from 2.4 GB or 2.2 GB of memory usage, we came back down to about 1.5 to 1.6 GB of memory use. So that's a big win without changing a single line of a code. Next is reduce the object creation. So that's the most essential part of debugging the memory issues, and quite vast as well, because there are many places or many ways in which the object creation could be happening. One of the common one is n plus 1 queries. So because of the active records n plus 1 queries, not just that the number of queries that are happening to your application are increased, it also allocates more and more objects when doing that, and because of that your object allocation number could go up and the memories could spike because of that. So that's one, active record n plus 1 queries, fix that. Second is active records unused large columns. So one of the example that I have here is about this. So you have user table, you call user.all, and this is the default query that is generated, which is select users.star from users. So the users.star is taking all the columns that are there in a user model, and that's the problem, because sometimes that user model could have 15 or 20 columns as well. I know it would generally be a best practice to keep things different if they are not required, meaning that if a user has a profile and profile has many other things or sort of things, then you should probably have a profile as a separate table and a user as a separate table, thereby making sure that users table does not have a huge list of columns, right? But if it has, and then you are calling users.star, then basically you have many objects being allocated. So that's about that. Next is delegate to DB as much as possible, specifically for reports. So this is the case where you have some of the pages or some of the reports or graphs where you need to touch a lot of records in your database, not just from the single model, but sometimes from the different models as well. And at that time, if you are doing all of that work in the Ruby, then that is a problem because you are basically creating a lot of objects in the Ruby, and it's not ideally recommended. So the better way for that is to delegate that to the database as much as possible. So all these summarization tasks, counting tasks, or if you have advanced reports, then you could also go for views in the database so that all these calculations happen there and then come out ready for you. So next is freeze. So having a freeze tells Ruby that this object or this string is not going to be changed, and then Ruby basically caches or reuses that whenever a call for that string happens, and because of that, less number of objects are created. And then finally, iterate versus collection rendering for partials. For example, this is one of the common issues that we see. So the first one is the wrong code, second one is the right code. In the wrong code, we see that, so this is a JBuilder template, and we are rendering a partial called as feed. What we are doing here is we have this feeds object. We are iterating on that feeds array, and then rendering a partial called as feed with local as a feed, right? The second one is the case where we are rendering that partial only once, but passing the array as a collection option. So these two code samples, different, they have a huge memory footprint. In the first case, what we are doing is we are iterating on that array. So every time a new feed item is created, and then we are assigning that to the feed. So all these partial rendering flow is triggered, which allocates its own object. For example, whenever you are doing a query through the active record, it's not just the records that you get are objects that are created. There are multiple places in the stack where object creation is also required, right? And because of that, the second one is more efficient because the partial is rendered once and the collection is taken as and rendered with that. So less amount of Rails code is what we are executing in these examples. And the third one is third solution that we could think of is take out the memory heavy work out. So many a times what happens is you have active admin like admin dashboard, which is also in the same application on the same server, and whenever someone tries to visit that and load all the records, by the way, active record comes with default searching options, which tries to basically have all the related records listed there as well, which is a very, very heavy memory operation, and that is also a problem. So the ideal way to do that is to have that admin application deployed on a separate stack itself, so that whichever users are using that, their memory usage won't affect the others. So that's the idea. So yeah, to summarize, we have to remove the unused code, second is to reduce the object creation, and third is to take out the memory heavy work out. So these are the three things that you should do. That's a summary. So in all, to summarize the entire talk, we have two parts to the memory problem. First is something that you have in your hand, and second is something that you don't have in your hand, which is the Ruby stack. Understanding the Ruby stack is important. Why something happens is why something is happening there. To know that is important. You can consider that memory usage as like having a momentum. Whenever you want to have a huge amount of memory used by your application code, remember that the usage has a momentum. Even if you are done using it, the memory won't get released. It has its momentum, it will come down slowly. So that's the point. Yeah, so with that, all these fixes added in, this is the next memory usage graph that we got. So as you can see, the memory usage mostly remains up to 384 or 400 MB of RAM. So from 2.2 GB of RAM, we brought down the process to up to 300 to 400 MB of RAM. That should probably considered as an ideal size of memory usage, and that application lived happily ever after as well. Not really, you have to keep working on that. So apart from that, there are just a couple of things on the development machine, like always monitor the bottlenecks. Like I was working with one of these front-end guy who was also knowledgeable a bit about the Rails application. So he was working on just the Haml side of it, but he has to obviously run the Rails application as well. But every time the Rails application, or whenever he tried to change something in the style sheets, which were the SAS, he did one change and refreshes the page, and he has to wait for like 10 seconds to recompile all the assets and then reload the application and then show it to him. So these are the things where people sometimes, or some of the team members of yours might face the issues, and it's always good to monitor the bottleneck and check whether it's a processor that is bottleneck or the memory that is bottleneck. And in maximum cases, it will the memory that will be the bottleneck. So. And secondly, that SSD is worth your time. Like there is a good old joke, people tell each other that, what is a good way to convince someone to be a Ruby programmer? Tell them how much you get paid, right? So that SSD is worth your investment, and you should consider. And I think 8 GB and SSD should be considered as a minimum amount of machine configuration that is required for any of the development machines. So yeah, that's all. Thank you.
Thanks, Ratnadeep. That was an awesome talk. I think we have time for one question. We can take one question.
Can you name some of the tools you use to get the metrics out and to observe them?
Yeah, so the derailed was one which was about giving the object allocations and the memory allocation by the each gem. So that's one to debug the gem. When it comes to debugging your own code, so one option to that is to use memory profiler, and apart from that, so there are a couple of other gems, but the memory profile is the one I used. Apart from that, if you are on the Rails console as well and wanted to check some of the scopes or other parts that separately check the allocations with that, then GC stat is also good. Directly talking with the GC also, it provides you with the good numbers. So apart from that, for simplistic things like this, Skylight, which is developed by the Yehuda, the agent they have is pretty light, and it provides all the requests sorted by amount of RAM that they are using, number of queries that they are doing, and object allocations that are happening in those things. So if you want to check everything or just the deployed applications performance, then I think that is a better way to go. Scout or this one. I think I tried New Relic as well, but that wasn't as detailed as Skylight. So the Skylight has very few pages, like just 2-page application, but still it's quite informative.
All right. Thanks, Ratnadeep. That was an awesome talk. So before we start the next talk, I just want to add to what he was saying about Skylight. So problem with Skylight for a lot of people was that it didn't support background jobs for a long time, but now Skylight is also supporting metrics for background jobs. So if you want to try Skylight now, it is possible to debug your Sidekick or rescue jobs as well.